This is question 6 of the Natural Sciences Admissions Assessment, paper 2016. And this question is about bearings. So we have a point A, which is 4 kilometres due east of point B, and a point C, which is at a bearing 330 degrees from A and 60 degrees from B, and we want to find the distance BC. Now, it's very hard to find, to get our head around all this information without drawing a picture, so let's try and draw out what exactly is going on. So we're going to start with B. So let's just draw B on with its north arrow pointing upwards like this, and A is 4 kilometres due east of B, so east is over this direction here. So A is going to look something like this, and this length is 4 kilometres. We've got our north on A as well. So now we're going to draw on the bearings for C, so 330 degrees, and remember we measure bearings clockwise from north, so we're going to start north and go round clockwise 330 degrees, something like this. Similarly with B, we have 60 degrees, so something like this. So you can imagine lines coming up here, and C is where they join in the middle. So C is somewhere up here, and we get a triangle that looks something like this. So pause the video for a second and just have a think about what you think we're going to do next. Now we've looked at this picture, can you think of any rules or any information we could extract from this to work out what's going on in order to find BC, the length here? Okay, so we can look and extract out this triangle here. So it looks something like this, with this is 4 kilometres. And first thing we want to do is find these angles here. So to do this, we're going to look at what we already know. So we have A is due east of B, so this line is completely horizontal, and the north is completely vertical, and so they're going to form a right angle here and here. And we know that this is 60 degrees, so the angle inside at B must make up the other 30 degrees, so that we have 90 altogether. So this must be 30 degrees. So pause the video and see if you can do something similar to work out the angle here at A. Okay, well, again, we have a 90 degree angle here, and we do 330 round here, so we know that to get to 360 degrees in the full circle, this bit up here must be 30 degrees, and so this bit at A must be 60 degrees. Now, we know that the angles in a triangle add to 180 degrees, so straight away we can see that C must be 90 degrees. So now can you think of a rule which links angles in a triangle and the sides of the triangle, which we could use to work out BC? Pause the video and see if you can come up with this rule. Okay, so the rule you should have thought of is the sine rule. So sine A over the length of side A is equal to sine B over the length of side B. And we can call A, B and C whichever ones we want. We've already got labels A, B and C, but we could switch them around if that's helpful. So we're going to consider this angle at A and the side BC, because that's what we want to try and find, and this angle at C and this side here, because we already know this, so we can use it to work out BC. So can you substitute these things into the sine rule? Have a go at doing this now. Okay, so you should get sine at C, which is 90 degrees, divided by small c, which is the side opposite the angle at C, so this side here, which is 4, is equal to sine 60 here, divided by the length of the side opposite A, so BC. So this is the length of the side BC. So now we need to work out what sine 90 and sine 60 are. If you can't work them out at the top of your head, you could draw out a table which looks something like this. So I have theta equals 0, 30, 45 and 60. And all I've done for sine theta is written 0, 1, 2, 3, square rooted them all, and then divided by 2. So that could be a quick way of working it out. So we substitute that in, and we get 1/4 is equal to root 3 over 2 divided by the length of BC. And so BC is equal to 2 root 3, and our answer is B.